Today I'm going to introduce you to a new coordinate system called polar coordinates. Polar coordinates are a coordinate system that is based on angles and distances. And we've got a couple of vocabulary terms related. First off is the pole. The pole is the origin of the polar plane. The polar coordinate system has just one axis, called the polar axis, and it's what you will think of as the positive x-axis. Alright, so let's talk about polar coordinates. Rather than having an x and a y, polar coordinates have an r and a theta. The r is the distance from the pole. Theta is the angle formed from the polar axis. Just like on your unit circle, if theta is positive, we go counterclockwise. If theta is negative, then we measure the angle going clockwise. So now we're going to graph some points. Alright, so this is what the polar plane looks like. It's different from your normal traditional x and y. But you can see it looks kind of like your unit circle. We've got different measures here. So this is from 0 to 90. Each of these are 15. I'm going to mark kind of our main ones there. So you can do this in degrees. You can do this in radians, where this would be pi over 6, pi over 4, pi over 3. And so on. I'm not going to label too much because the angles actually can appear different in the polar coordinate system. So we're going to graph some points. Okay, so if I wanted to graph the point 330, so my r is 3, my theta is 30. So I go out, so there's two ways to do this. You can go find the 30 degree and go out 1, 2, 3. Label that A, or you can go out 3 and then around 30. Let's do another one in radians. So I'm going to do 4 and 7 pi over 4. Okay, well 7 pi over 4 is down here, and you might want a unit circle handy when you do this. And then we're going out 1, 2, 3, 4. We'll call that guy B. Okay, 2 and negative 240. So rather than going counterclockwise, like we would on a normal unit circle, we're going clockwise 240 degrees. So regular 240 is right here. So negative 240 degrees is going to be up here. And then we're going to go out 2 units. Label that C. Okay, 2 and negative pi over 2. Positive pi over 2 is up here, which means negative pi over 2 is down here. And again, I have 2. Okay, we have a negative r value this time. So negative 5, positive 45. Again, there's two ways to think about this. You can go to the 45, and then rather than going to positive 5, you go backwards to negative 5. Or you can treat this like a number line and say if this is 5, that would make this -5, and then proceed going counterclockwise 45 degrees from that. So let's do another one of these. Okay, -3, 4 pi over 3. So I can go to 4 pi over 3, which is going to be this segment right here, and go backwards, 1, 2, 3. Or you can go to -3 and go counterclockwise to that point. So that's how we'll do a negative positive. What about a negative negative? -210 degrees. Okay, so I have a -4 and -210. So I can go to what would be -210, which would be, so this is 210, which makes -210 here, and then go -4, 1, 2, 3, 4 on that axis. Or you can go to -4 and go clockwise 210 degrees. All right, let's try one more. Okay, so if I want to go to negative pi over 6 is going to be down here. And then I'm going to go -3, which ends up here. Okay, so the positive and negatives don't react the same as they do in the rectangular coordinate plane. In the rectangular coordinate plane, if you have a negative negative, it's always going to be in the third quadrant. Here, it can be in any quadrant. So let's do an example with that idea. Okay, so we're going to find 3 other coordinates that represent 2, 210 when -360 is less than theta is less than 360. So this restriction's here because I could just keep adding 360 and then I'd have 3 coordinates. But here we've got to think of how to do this in a variety of different ways. So we're going to answer this. Go ahead and do a graph just so it's easier to see it. So the point 2, 210 is going to be right here. Okay, so I'm going to go to that same coordinate with a positive negative, a negative positive, and a negative negative. All right, so first a negative, or a positive negative. The r isn't going to change. R is still going to be 2. We went this direction to 10, so negatively we're going this direction, which is going to be 150. Okay, if I have a negative r, that's going to be a -2. So here I'm going to think about if I'm starting here at -2, what angle would I have to go counterclockwise to get here? So this is going to go from here to here, which is going to be 30 degrees. Okay, now if I started at -2 and I went clockwise all the way around here, that angle is going to be 330. So -2, -330. All right, so I want you to try 3 and 5 pi over 6. So if I were to graph 3, 5 pi over 6, okay, we're going to be right here. So I want to do the same thing where I want the positive negative, negative positive, and negative negative. All right, so for positive negative, my r will still be 3, but rather than going this direction 5 pi over 6, we're going this direction 7 pi over 6. For the negative positive, picture starting here and going counterclockwise around this circle. That's going to be 11 pi over 6. So we have a negative 3, positive 11 pi over 6, negative 3. So again, starting here but going clockwise, it is just going to be that little part there. So that'll just be pi over 6. Okay, next we're going to graph some basic graphs. We'll be able to do some really cool things in this polar coordinate system, but for right now we're just going to stick with some pretty basic ones. The first thing that this lends it to pretty easily is circles. Okay, circles are going to be in the form r equals something. So let's say r equals 3. Well, that's going to be all of the coordinates who have an r value of 3. So we're going to go to 1, 2, 3. Here would be 3, 0, 3, 15, 3, 30, and so on. So what it ends up being is a circle at r equals 3. Okay, what if it was a negative? R equals negative 2. Well, that's going to be all the points that have an r value of negative 2 here and here. So it would be the same thing as if we had r equals 2. Okay, the other thing we can draw are lines. So let's say I wanted to graph the line. These are going to be in the form theta equals 3 pi over 4. Okay, so I'd go to 3 pi over 4, which is here. Those would be all the positive r with a theta of 3 pi over 4. These would be all the negative. Okay, what if I wanted theta equals negative 330, or something like that? Well, negative 330. Positive 330 is here, so negative 330 all the way around here would be this line right here. So this has been your introduction to the polar coordinate system.